He's a data scientist, a data analyst, working for the NASA, working for a startup in New York, and now working for a French startup called Snips. And I think he's one of the best keynote speakers we can find right now for our main topic today, the question about context. So we all thought about content is king, but now we're living in the age where we have so much context. And now I want to introduce Joseph Dureau with his keynote about context. Welcome. Good to have you here.
Okay, so you can all hear me, yeah? So first of all, I'm sorry, I'm a little sick, so you'll have to bear with my French accent on top of my sick guy accent. So I hope that's going to be all right. So I'll start the talk by defining what context awareness is. So it's the idea that devices and software can sense and react to the current situation. So I'm going to give you some examples. So first of all, the simplest form of all of context awareness is a kind of rules of if this, then that. And actually there's an app that does that. So it's called Ifttt for if this, then that. And actually you can manually set up rules so that in a given condition, a reaction is triggered. So for example, here with this app, you can say, okay, whenever it's going to rain, I want you to send me a text message. So that's like the simplest form of context awareness. And that's like a manually set up form of context awareness. So then there's everything about retail. So I don't know if you've ever heard of beacons, but those are like sensors that you can put in your stores. And basically they're going to sense whenever someone enters your store, and then you can send notification to your users. So those are like, you have interesting applications of this. But maybe one of the most famous examples of context awareness is the Google Now application. So basically what they try to do with this application is they try to guess the information you want to have access to, and they provide it to you in forms of cards, so you don't even have to look for it. A really interesting piece of hardware that's context aware is the Nest thermostat. So basically that's something you have in your home that controls the heat, the temperature of your place. And this thing is context aware, and not only it's going to learn about you and the temperature you like, but actually it's capable of doing things like communicating with your car, and basically when you're leaving work and you're on your way back to home, actually the Nest thermostat is going to receive a message from your car that is going to tell you, okay, you should start heating up the house now, so that when the user comes to the house is warm and cozy. So these are like kind of really cool interactions that you can set up with these context-aware hardwares. And actually they've set up a program that's called Works with Nest. And actually this device, so it's already smart in itself, and it's able to communicate with other smart devices. So for example, here it's the Jawbone bracelet. So that's like a health tracker that you can wear. And actually this bracelet is able to track whenever you're waking up. And actually this bracelet is going to be able to communicate with your thermostat to tell it, okay, the user is waking up, you'd better start heating up the house. And this is really interesting because not only you're starting to have like context-aware devices, but also you're starting to have an environment of these devices that communicate between themselves and provide an even improved experience for you. A French example of a context-aware hardware is a company called Sense, and they have a product that's called Mother. And basically those are like multi-function sensors that you can basically stick anywhere and respond to a set of given scenarios. So for example here, you can put one of these sensors on top of your coffee machine, and actually what it's going to do is going to send you a text message whenever you're going to run out of coffee. Or you can put it in the backpack of your son, and actually whenever your son comes back from school and gets to home, you get a text message. Or another example is that you can put it on the pill case of your grandmother, and every time she forgets to take her medications, you get a message. So there have like all the set of scenarios where you can use these trackers for all kind of things, which is very interesting. This one is a project that appeared on Kickstarter, and actually this device here, the hardware in the middle, is called Prism. And what it does is that it's actually able to sense the people that are in the room. It's able to access the musical tastes of these people, and it's able to sense the atmosphere of the room, and it's going to play a different playlist adapted to the people that are there and to the atmosphere. So for example, if you're having a romantic dinner with your girlfriend, it's going to play different music than if you were in a crazy party with all your friends. But maybe the most extreme example of context awareness is a self-driving car. So here's the Google car. And these things, so not only do they capture when the user moves, that's not really the point. What they do is they have to have a consciousness of all the environments, so all the street topology, all the traffic conditions, and also they have to sense all the streets and all the cars and people that are around, and to understand how they're moving and potentially try to predict what they're going to do to react accordingly. So this is a really extreme example of context awareness, and that what's really fascinating is that it's actually starting to work, and from the results we're hearing, these things are already safer than humans driving them. So this is really exciting stuff. So how do we represent and comprehend context at Snips in my company? So we represent it as a 3 layers system. So you have one that's the personal layer. So the personal layer is everything we know about the user. So he states what he likes, what he does. And then there's the social layer. That's basically all the network of people he's engaging with. So that would be his family, that would be the people he works with, his friends, all of this. And then you have the external layer. That's basically everything that you need to have consciousness of, but that doesn't have a direct link to your user. So I'm going to dive into this external layer to give you some examples. Okay. So one aspect you may want to comprehend when you're looking at the environment is, for example, the public transport network. And for example, here, it shows you in real time the number of people that are taking the metro, and that thanks to this, you have a consciousness of what are the peak hours when the metros are going to be crowded or not. And also, something you're interested in is the state of the network. And for example, if you have perturbation, you may want to be aware of that to bring notifications to your users. Also, something else that could be interesting is all the events happening in the city. So, for example, if you have for example, here a Lady Gaga concert, well, you want to be aware of this. So potentially that could be interesting to the users. So maybe you want to notify him of that. But actually, that has other implications, because actually, if he's going to drive somewhere by the stadium here, he may run into trouble. So you may want to be conscious of that and take that into account when you're bringing advice or directions to your user. One key component of the environment is also the places. So actually, luckily or unluckily for us, you have databases of places like this, but they're private. So here I gave the example of Foursquare, and this is critical. So what I mean by places is like basically anything. So that's restaurants, that's bars, that's stores, that's bus stations, metro stations, that's basically everything. And actually, as soon as you start trying to build a context-aware application, very often you run into this need of having to know all the places around the user to orient him in a nice way. And the problem is that when you enter this kind of market and you want to build something, you don't have access to the databases because you have to pay for them, and at the beginning you don't have money. So actually what we're trying to do, so we see this as a kind of a big problem, and we're trying to build an app right now that actually will enable users to track themselves along the day, and at the end of the day they will easily be able to tag all the places they've been and to share that information as open data. And what we're trying to build with this application is actually a public and a good quality database of places. So we feel this is pretty critical, and that's why we're moving forward in that direction. Another element of context that's very important is the weather. So that has a strong influence on what you're going to do and the way you're going to go from one place to another. And one last element of context that's very important is the topology of the city. Depending on the things you want to build, this could be critical to a critical dimension of the context that you may want to take into account. So when you have all these sources of information and you bring them together, so this slide shows you a little bit the kind of depth of understanding you can have and the kind of experience and advices you can bring to your users. So for example, here, you know that one street is pretty fluid, in the other ones you have construction work, so this one may be less fluid, so you want to take that into account when you're giving advice to your user. You know also that here in the corner, in the top corner, you have a restaurant that actually is well rated and that has a very short waiting time. So if the user is having a lunch break and doesn't have a lot of time, you may want to take that into account to give him advice on where he should go. So those are some examples. And now I'm going to give you examples of applications we've actually built with this environmental layer of the user context. So this is an application that's called Tranquillien that we built in collaboration with a train company in France. And basically what it does is it looks at historical data and the current conditions to build predictions of how many people are going to be in the metros and in the trades. And that's useful, well, on one side it's useful for the user, because if he has time, basically he can decide to leave, I don't know, 15 minutes later or 30 minutes later to have a more relaxed trip and be able to sit in the train. So that's interesting on his side. But actually, it's also really interesting to have this kind of applications on the side of the train company, because some users are going to decide to delay the departure, and actually that's going to flatten the peaks of frequentation of their transportation network. So these kind of applications bring good things on the both sides. One other example, here it's an application that we did in New York, and this application, it uses historical data to give you the places where you have a chance to get a place to park, and also it's going to give you an indication of the time you'll have to spend finding a place to park. Another really cool application we've made, I really like this one, it's called Sun Therapy, and basically what it does, it models the way that the sun is going to reflect on the houses of the city, and actually it's going to tell you at a given time of the day and on a given day of the year, what are the cafes in which you have a chance of sitting in the sun. So that's pretty cool, and especially right now as the summer is coming. So one last example that we call a safe signal. Okay, working. Okay, so this one is in San Francisco. So what it does is, again, it looks at historical data of accidents, and it looks at the current conditions, so the topology of the streets, the weather, and many other features. And actually it builds a risk model of having an accident in every segment of street. And what's interesting is that if you're driving, it can tell you, okay, here you're in a especially dangerous place, and you should be extra careful. So that's an interesting application we did as well. And you see that for the moment, we've only been looking at the environmental layer. And actually, we've been doing that for a couple of years. And after a couple of years, like, things were going really well. We had like different projects going on. And actually, we realized that in everything we were doing, we were not really putting the user at the center. And also, like, we were bringing new apps to the phones. But actually, we all felt that there was something somehow broken in the way we interacted with our phones, in the interfaces of our phones. And so we started being interested in a field called real-life computer interaction. And to give you a feeling of why we feel these interactions that we have with our phones are broken, I'm going to give you an example. So let's say I have a meeting. So the first thing I do is I open my calendar app, and I look for the address I need to go to. So I copy and paste this address, and I open Google Maps or City Mapper, and I just paste the address there to have an idea on how long it's going to take me to go there by public transport. So let's say I'm a little bit late, or the trip is a bit complicated. I want to look at what's available on the taxi sites. So I open a taxi app. Then again, I paste my destination address. I look for it, and I get an idea of how long it's going to take to me, and how much it's going to cost to me. But then maybe it's potentially a bit expensive, so I want to look at what Uber has to give me. So I open the Uber app, again I paste, I get information on this, and then I have all the information I want to make up my decision. And when I'm on my way to go to the meeting, again I'm going to open my calendar app and look at the people I'm going to meet, because I like to open the LinkedIn profiles of the people I'm meeting to have some context before I meet them. So all in all, for one meeting, I've spent 6 minutes on my smartphone. I opened 5 apps. I had to type 250 keystrokes, and I made 17 typos in the process. And this, we feel, is really broken. We feel that doesn't feel the right way, because like, my phone has been sitting in my pocket for several years. We call it a smartphone, and yet, anytime I'm in a given situation, it's not able to facilitate my life to get access to the right applications and to the right information. And it's always like that. When I have a meeting, so there's a set of applications, and there's a kind of information I'm looking for. When I'm night clubbing, for example, with a friend, it's different applications, different information, but always the same. When I'm traveling abroad, again, same. Different set of applications, different kind of information, and it's always repeating itself. So, you know, like, you have really patterns in that, and you could hope that your phone could take advantage of those patterns to just make your life easier. So the approach we've taken to this is something that looks like this. So this is the home screen of the application we're currently working with. So what it does, it takes your context, and it tries to predict your intention and needs, and it gives you shortcuts to all kinds of information and then potentially to applications that you might be interested in. So let's set the context here. So let's say I'm at a cafe in Paris and I have a meeting with a guy called Ran Hindi, which is actually my CEO, at the snips office. So here I have a set of links. And if, for example, if I click on the one that says go to snips office, I get to a screen. And I don't know if that reminds you something, but that's exactly what I would like when I go somewhere. This is a summary of all the information provided by all the different apps that I have on my phone that tell me the time to arrival and the price to get somewhere. And in just one click, I have all the information I need to make a decision on how I'm going to go somewhere. So the way we populate these things is just like every application has an open API, so that's like common practice right now. And APIs are basically the way that apps can talk to each other and just ask questions to each other. So this is completely feasible with the current state of the art, and that's how it works. And actually, each of these lines is something we call a deep link. So a link is like similar to the links you have on the web, but actually it's a link between an app and another app. So here, if I click on the first one, so the Uber pop, so not only it's going to open Uber, but also it's going to open Uber with the fields already filled. Because Snips knows where I am, because it knows where I'm going to, well, I don't have to fill anything in Uber, and I just have to make one click to book my Uber. So if you compare that to the experience where I had to open 5 apps to make my choice, and then enter all the information in the right app to book the right service, here you've had 2 clicks to book your Uber, and why have we been able to do this? Is because this pattern keeps repeating itself. So let's take another example. So let's say, for example, here I'm clicking on the Ran Hindi, and here I have all the relevant actions I could want to have with relation to him. So potentially I have the list of all the ways I can have to contact him. So for example, I can call him, send a message, send a WhatsApp, Skype him, talk to him by LinkedIn. Actually, I can also have access to his LinkedIn profile, and I can do other things like share my location with him, or go to his office, or go to his house, like whatever is relevant to him, because I've given some context. I'm in a given place, and I'm interested in a given guy, and I have all of these options to interact with him. So let's maybe a last example. So here you see at the top, so the app has been able to detect that I'm in a given cafe. And actually, if I click on it, potentially I'll have a deep link to PayPal if I want to pay. I'll have a deep link to Foursquare if I'm interested in tips and reviews that people have put on Foursquare on this cafe. Or potentially I'll be able to check in Foursquare. Or one last thing, potentially if actually I like reading the news when I'm having coffee, well, here I would have a deep link to the news application that I usually open when I'm in these kind of places. So how does that work? How we make this possible? So actually what we do is we cross open data with your personal data, and the first source of data we use on you is your calendar data. So this is a calendar of someone that's pretty busy, but if you look at it, for each item you have a description of the action, and you can analyze this and to get information of what the person is going to do. So let's take an example. So something that people will write pretty often is like something like meeting with Oliver. Okay, so first of all, you need to do language processing on that to know that meeting is an action and Oliver is a person. So, okay, so that's already a challenge, but that's pretty standard. But then, meeting with Oliver, when you know that Oliver is a person, well, actually, if you want to make decisions on it and like just give a link for the user to connect to Oliver, you need to know which Oliver it is. And if you have several Olivers in your contact database, that may be problematic. So actually, language processing is not enough, and the way we do it is we look at the context. So for example, we know that this meeting is during work time. And actually at work, there's a guy called Oliver. So it's probably that guy. So actually we use the context to disambiguate the information that's in the calendar to take the most out of it. So that's one aspect, and that's one source of data. But maybe the most important source of data we're using are location data. So your phone captures location all along the day. So that's 1 day of location data of a user in London. And if you see the circles, they're like an estimation of the accuracy of the location measurements. And actually what people don't realize is that phones are pretty bad at identifying a user's location. So if you look at this, so those are like a series of location measurements that the phone has given us for a given user. And during all that period of time, the user was actually still. So he was in a given place. He wasn't moving. And all of these locations are what we have. So actually, when you look at this, it's not obvious that he was still. And even if you guess he was still, it's not obvious where he was and what he was actually doing. So we have algorithms to do this. So for example, the first algorithm, what it does, it tries to identify the periods in which you're transiting from one place to another and the periods in which you're still in a place. And actually, you're going to tell me, OK, you have an accelerometer in your phone, so it's not that hard. Actually, it is, because your accelerometer may detect that you're walking. But for example, here, like we've all been walking in the conference hall, but actually, we've been still in the same reference that's this conference hall. So what we're interested in is if we're still in this place and we're transiting between places, because that's really the kind of information we may want to use in a contextual interface. And that's not easy to guess. So we have a first layer of algorithms that do this. So we get to this kind of things. So we've been able to identify, or at least to have an estimate of where the user is. So that's the purple dot. And you have a notion of uncertainty of our estimation. And then the green lines are estimates of the trajectory the user took when he was transiting from one place to another. So that's interesting. You can already make up things out of this. But actually, we're interested in where the guy actually is and what he's doing. And actually, you need to know, for example, if you was a restaurant, you need to know that. So what you do is you look at places around, right? And you get something like that. Every dot on this slide is a different place. So it's hard to imagine the concentration of place you have in cities. And actually, when you compare that to the resolution of the estimation of the location you had on the user, it's really hard to tell where he was, right? Like even in the radius I given, so all of these places are potentially places where he was. Like, because of the noise you have in the location and the uncertainty you have, he could basically be anywhere here. So what we do, we have models probabilistic models that are going to give weights to the different places to try to guess where the user was. So this thing has two layers. So the first layer we use is a layer that uses the contextual features. So for example, if we're at lunchtime and we have a restaurant and you have a nightclub, well, it's more likely that the user is in the restaurant than in the nightclub. So that enables already a first filtering and weighting of the places. And then we have a second layer. It's a reinforcement layer. It's something that learns about the user. And for example, if in the past we've been able to identify with a good accuracy that you were in the Starbucks, well, next time you're going to be close to a Starbucks, we're going to put more weight on the Starbucks than on the other places. And actually, by trying to mixing this, so all the contextual features and everything we're learning about you, we're getting pretty good results on guessing where you were. And for example, here, our model says that the guy was at Café La Prêche, which was actually true. And you see that this was actually not the obvious answer, because it's by far not the closest place to the estimation of the location we had, which is the red dot in the middle here. So once we do this, so we have all the network data, we have all your calendar data, we have all your location data that we have analyzed. With all of this, we cross it, and we're able to build a really contextualized time series of what the user has been doing a long time. And this is the key, and this is the way we store data, and this is what all of our algorithms takes as input, and that's what we use to try to predict the context of the user and his future intentions. So this is really nice, because we think that based on this knowledge, we're able to build this kind of interfaces that are going to transform the way we use mobile phones. And one cool implication of this is that, as I said, look, we often hear that there's an app for everything, which is pretty much true, right? When you look at the App Store, basically you really have an app for everything. But if you made the decision to install all the apps for every use case on your phone becomes a nightmare. Like you have to scroll to the fifth page and go into a folder to get the right application for the right use you may want to have. When you have this kind of interfaces that are not application-centric, but they're user-centric, and they start from the user and his intention, and will provide to him the right application they have installed on their phone exactly at the moment they need it, well, then you open up the door to having like hundreds of applications on your mobile phone, or potentially 1,000 applications on your mobile phone. And then the experience is completely transformed. So that's one thing we can do with mobile phones, and we're excited that now we have the technology to enable these kind of things. But when you look at other devices, so for example, smartwatches, Well, this thing is not only nice, it actually is required, because you have no way to, you're not going to juggle between 5 apps on your phone, on your watch, right? And you have no way to enter data. So actually, for the watch to be really useful, you need the watch to understand your context and your intentions, and to bring you quick access to the information and actions that you may want to launch and have access to. So that's for watches, but if you think about like 2020, at a time where we're going to connect to interact with tens of devices every day. So that's going to be the phone, the watch, our shoes, our bracelet, our car, our fridge, our coffee machine, like everything will be connected. At that time, if we haven't figured out a way to completely transform the way we interact with technologies, that period is actually going to become hell. Like you're going to spend your day just interacting with technology and setting up the settings for each of these things. There's no way that's going to happen. So actually, that's really the target we have at Snips, is to build the technology and the interfaces so that we create a real symbiosis between technology and your real life. So basically, that was the end of my talk until today, and I've been told yesterday that maybe it's going to be hard to do questions and answers. So actually, I've inferred the question that you were going to ask me, because I guess that in the top of most of your minds, you have this question. What about privacy?
Do we have a question about privacy?
Oh, if you don't want me to talk about it, I can just go see it.
I'm prepared with 2 questions.
Okay.
I'm prepared with 2 questions. And when I follow your keynote, so privacy is one concern we could have, like how many access do we have to give to your app or to other apps? So we already know the situation that we are using an app like WhatsApp, and then the app asks us, may I access your microphone, your camera, or your whatever? And the future apps will ask me, may I access your calendar, your address book, your whatever, your Fitbit, the tracker, all your wearables? And maybe that's the next question we'll see on these devices, right?
Exactly.
Yeah.
Okay, yeah, so I have some elements of answer for that. So exactly the way you said, so for the moment, like basically every app that you install on your phone asks you for permission, and for example, like every app that's even remotely linked to the notion of location will ask you for the authorization to access your location. And as I've showed you in the previous slides, actually there's a lot of information about you in your location, and you don't want to be giving out this to everyone. So one vision we have of the way to address this problem is actually to have one app, because like your data is a serious stuff and it's a complicated stuff. So the idea would be to have one provider that collects your raw data and analyzes the same way I've shown you, and like from this data infers like high-level features and communicates only these relevant features to the apps that need it. So for example, this app here, it's a social network of kiteboarders. And the reason they want your location is because they want to be able to ping you whenever there's someone from the network that's close to you. But actually, instead of giving this app the access to all your location data, you could just make a link, the same way you had a link between your car and the Nest thermostat, a link that gives the only tiny bit of information that this app needs to work. So what you would have instead of this is allow North Kiteboarding to have a notification from Snips every time you're close from one of the users. And it could be Snips, but actually we're not the only ones thinking that way. Actually, Apple is trying to create these kind of things with like smart APIs that talk to the apps on your phone. Google is trying to do the same, so it's either be them or us or someone else. But this is the direction everyone is going to, because this situation really cannot last. This is crazy periods, and that's gonna end soon. And so that's one way of seeing things. And also we take this issue really seriously at Sims. So we have like 3 solutions we've built, 3 approaches to really improve the way we deal with your data and your privacy. So the first 2 ways we tackle this is like in UX terms. So we really give you control over the data we capture about you. So first of all, we have a do not track button in the app that's like directly accessible, and you just click on it whenever you don't want to be tracked. So for example, you're going to do something that you're not very proud of. So I don't know, you're going to cheat on your wife. The last thing you want is you want the app to track everything you're doing. So here you click on it, and the app won't know anything about whatever you've done during that period. So that's one aspect of it. So let's say you've done something you're not proud of, but you've forgotten to click on the button. Well, actually, we provide you with a quick visualization of all the data we have on you, and because we store the data we have on you in this format, which is an intuitive time series of what you've been doing a long time, well, it's easy for you to understand the data we have on you, and it's easy for you to erase any bit of it. And because that's the data we have and we use in all of our algorithms, as soon as you've erased part of it, well, it's like it never happened for us. So those are like two UX-based approaches we have to give control to the users onto the data. But I think we can go much further. And the way we do this is that we look at the way things work right now. And the way things work is that you have phones that collect data, and they send the data to a server where the data is processed, and then the user has to trust the service to not sell the data to someone else or not do things with the data it's not supposed to do. So actually, for us, when we looked at the problem that way, well, maybe one solution is to never send the data to the server. So eventually, if you move all the algorithms and all the calculations from the server to the device, we actually don't even have the user to trust you, because actually you never saw his data. So I think we're pushing things that way, and actually it's a bit challenging because you can imagine that the smartphone doesn't have the same computation power that what you can do on the server. So it's a challenge, but like phones are getting better and better, and this is becoming possible, and we already have a good chunk of our algorithms that run on device. And I think that's the objective we're setting for ourselves, and we think this is like a true solution and a true answer to the concern of privacy data.
Perfect. So I would have another question for you,
Sure.
maybe addressing another target group in the audience, not only us as consumers sharing our data with the public or with some companies, but also being entrepreneurs building our own apps and ecosystems. What do you mean, what do you think? Do we need all to have our own APIs, really strong APIs, open data structure to feed apps like yours or the kiteboarding app with data that we can use in context?
Well, that depends. What do you mean by really strong APIs? Like,
no, APIs others could work with. So you talked about the public transport systems. So it's not that easy at the moment to get to data from public transport systems in Germany. So maybe they need better apps. So they need better APIs to get accessed.
yeah, I think that's a critical aspect of it. And everything we do is fed by open APIs. So either open APIs or APIs that we set up through agreements with private partners. But yeah, actually I think that's a key aspect, and these kind of things can only appear when there's the right environment for it. So for example, in France, you have different sources of APIs, but actually it shouldn't be our work to to merge all this information together. And actually you have already things are going in the right direction, because you have actors that actually their mission is to aggregate data and create the APIs. So for example, we have something that's called navisha.io, and these guys, they've done an amazing work, and actually we use their work to feed our algorithm. So this is critical. We need this kind of APIs and this kind of environment to build this kind of intelligent solutions.
Thank you, Joseph Dureau.